Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019 Time Zone 2 in May, question number 27, relating to stuff from topic 8, excellent basis, especially the concept of the ionic product of water. Let's see. The following equation represents the dissociation of water, also known as the self-dissociation, right? When water collides with water, it just breaks into hydronium and hydroxide ion. And given that the delta H of this forward reaction is going to be endothermic, right? Let's see. Which changes occur as temperature increases? So this is simply applies also for a concept from topic 7, the Le Chatelier's principle, that states when temperature increases, according to understanding, the endothermic reaction is being promoted more, right? So that means in this case, the equilibrium position is being pushed or so-called shift according to the endothermic side to a bigger extent. So in this case, the endothermic side is given to be forward, right? Forward. So that's what we expect is that when we increase the temperature, the equilibrium position in this case is going to be shifted to right-hand side. So simply implies that the concentration of the hydronium ion and also the hydroxide ion is going to be increased to the same extent. Why? Because according to the mole ratio states no matter how much of the water dissociates, still we got the same amount of moles for the hydronium and hydroxide. So that's why both sides increase. But if they are just asking for hydronium ion, still we get to the result is going to be increased according to the Le Chatelier's principle. So increase and increase, not decrease, right? And so because we know based on pH, because pH is just merely look at the concentration of hydronium and by taking negative log from it, right? Higher the proton concentration will leading to a lower value of the pH because of the simple mathematics, right? Increase in the value before you take log and negative resulting in a smaller number. So that's why in this case the pH will then be decreased but not increased, right? So this is the concept that leading to A. Yeah, but just want to mention a really important concept behind this logic is that true for pure water, when temperature increases for pure water, right? When temperature increases, the proton concentration, or simply now known as the hydronium ion concentration, is increased. Yes, seems like the pH is decreased, but don't think that in the case of water, particularly for the case of water, don't think that the solution is going to be more acidic. This concept is not applied to pure water, and this is a really kind of abstract concept that quite a lot of students don't really understand. That's all because true that for temperature increase, we have a greater proton concentration, brilliant. But then don't forget that our hydroxide ion is actually increased to the same extent. So this is the really important concept because both the hydronium or proton and hydroxide ion are increased to the same extent according to the recipe 1:1 ratio. So that's why the pOH is actually still decreased and both decreased to the same extent. So that's why because at the end I'm still achieving the same proton concentration with the hydroxide concentration. So that's why all in all water is still neutral. So this is a really important concept. Apply, remember, for just water and just pure water that I don't add any solute inside, because for this self-dissociation, no matter I'm having a bigger extent or lower extent of dissociation, I'm still resulting in the same concentration of hydronium and the hydroxide ion. So all in all, the pH is equivalent to the pOH, and so that's why water is still remain neutral. No, although the pH is going to be dropped. This is the most abstract point that only focusing on a pure water situation. Although they are not asking this kind of case in this time, still students are required to know this fact that the pH of water is temperature dependent. That if the temperature changes, the pH of water is changing. But no matter how it changes, water is still neutral. Really important. So particularly for this example, the answer will then be A, but the concept demonstrated is of higher importance.